Hi everybody, welcome to You Can Do Math, and today we are going to learn about if an inequality has no solution or infinitely many solutions. All right guys, let's get started. All right guys, so we have three examples for today. I'm going to do the first two and then the third one is going to be for you. So for example number one, we would like to solve this inequality. And so the whole point is if this inequality is going to be no solution or if it's going to be all real numbers, and what does that look like? What does that solution look like also on a graph? All right, so the first thing that we're going to want to do is we're going to want to distribute the -6 to both terms. And then we have -6x plus 12. And then we also want to distribute the 3 as well. Is greater than or equal to, distribute that 3, we get -24 and a -6x. All right, from there, let's go ahead and what do we want to do? It's up to you, but I notice on each side of the inequality that there's no combining like terms. So, and I notice I have the -6x and the -6x on each side. So I'm going to add the 6x to each side and see what happens. I'm now left with 12 is greater than or equal to a -24 because both of our x's cancel. All right, so now we have to think about the solution that we just received. It reads, that 12 is greater than or equal to -24. So then is that a true statement or a false statement? Is 12 greater than or equal to -24? And it is greater than -24. So this is a true statement. When we have a true statement, our variables cancel and we're left with a true statement, then we know that that is all real numbers. And all real numbers means that any number that you plug into this original inequality, any number that you plug in for x, will make a true statement. And so the final answer, right, is all real numbers. Now, why do we say real? Why can't we just say every number? Well, because there are imaginary numbers, and you guys are going to learn all about the beauty of imaginary numbers in Algebra 2. So we have to put in real because there are different types of solutions that we're not there yet, but we know that they're coming. All right, so let's take a look at example number 2. So for example number 2, again, let's go ahead and distribute. So I have a +2 minus 8x is less than a -16 minus 8x. And then this +5 just kind of comes straight down. All right, now I do need to combine my like terms on the right-hand side here before I do anything else. So I'm going to get into that habit of rewriting this side. 2 minus 8x is less than, and then my two like terms here, -16 plus 5 is -11, minus the 8x. And then I think I'm going to tackle those x's, right? I'm going to add the 8x to each side. And when I do that, I notice that they will cancel. And what I'm left with is the statement 2 is less than -11. So I just bring down those two terms. And now we have to evaluate or make a decision. Is this true statement or is it a false statement? Is 2, right? Is 2 less than -11? No, it is not. So therefore, this is not a true statement. So not true statement. And we say that there is no solution here. So we're going to say no solution. No solution means that there is no number in the world that you can plug into the original inequality for x and it will make a true statement. Doesn't work. So our answer, no solution. All right, are you ready to try one on your own? I really hope that you do. I hope that you pause this video and really try it out. So here is example number 3. Take some time and write it down, and then press play when you are ready. Okay, let's go ahead and see how you did. I'm going to distribute the 4 to each term. So I have 12x minus 4 is greater than, and I'm also going to distribute the 6 over here to give me 12x plus 6, and then I'm going to bring down that negative 10. Now I do need to combine like terms on the right hand side here, just like that last problem. So when I do that, I'm going to write down the left side, the 12x minus 4 is greater than, and then I have 12x and 6 minus 10 gives us a negative 4. So when you were doing this problem, did you notice both sides are exactly the same? And if that's the case, if they're exactly the same, should there be like a line here, greater than or equal to? Equal means they're exact same on the same value on each side. Okay, so what's missing to make that statement true? Let's go ahead and keep going. I'm interested to see kind of maybe what you did. Did you subtract the 12x from each side? And if you did, you would have been left with negative 4 is greater than negative 4. Now, is that a true statement? Is negative 4 greater than negative 4? No, it's equal to. And so therefore, this is a no solution, right? It doesn't make sense. It's not a true statement. Not a true statement. Which means there's no solution. No solution. All right, I hope you guys enjoyed this lesson for today, and I'll see you guys later. Bye.